Our next presenter coming up, Nathan Egge from Mozilla. AV1 1 year later. Welcome.
Thank you. Good morning. My name is Nathan Egge. I'm from Mozilla, and today I'll be talking to you about AV1. This is a 1 year later talk. I've got with me Brian Vibber from Wikimedia, and so he'll be joining me later on stage. But first, I want to just kind of maybe mention that I put the name of this talk in, I think, in February, and at the time there was a lot of activity around AV1, and I thought, wouldn't it be exciting to come up here and give you kind of like a year in review and talk about some of the new and innovative things that have been happening. Mistakes were made. I actually tried to do this talk at NAB, and it turns out that when you do a year in review of AV1 and there's all this activity, it's really hard to cover in 30 minutes, right? So here's me trying to do it. I had like 60 slides. It was very difficult to get through. And so what I'm going to do today, instead of doing the entire year in review, because this has already been done, there are links here if you want to check it out. The slides are online and the talk's online. What I'm going to do instead is I'm going to focus on maybe some of the highlights, but just the more recent few months since that talk. And with some of the extra time I reclaim, we've got a bunch of equipment here. We're going to try to do a few AV1 demos. Great. So one of the highlights of the past 4 months that I thought was pretty interesting that came out after NAB was, or at NAB, was this announcement of the SVT AV1 encoder. So this is another open source AV1 encoder brought to you by Intel and Netflix. And what's interesting about this, it's also got a BSD license, which is great. It means that people can take it and modify it and use it. But it has 3 different mechanisms it tries to use for achieving parallelism, right? So you've got your frame threading and your tile threading, but it's also got this sort of process parallelism where it can actually take parts of the encoder that you would normally run in serial and pull them out and run them in parallel. And by doing that, it then lets them create up to 13 different speed settings, right, by mixing and matching these pieces. And so this is actually a different way to achieve high performance than the other 2 open source AV1 encoders are attempting. And so that's novel and interesting, and it is basically trying to achieve a sweet spot in this sort of triangle of scalability, performance, and quality. All right, and so backing up a little bit, so at IDC last year, we demoed AV1 from YouTube right into the browser. This is Firefox 65, and at the time it was behind a flag, but shortly after that, we took it out from behind the flag, and also Chrome deployed AV1 in 7D, and Edge had it via a plugin from the App Store or the Microsoft Store. And so by the end of October, we actually had billions of devices with AV1 decoders on it, which is pretty exciting. So we thought, this is great, but of course, the problem is that the decoders that they have were actually kind of slow, right? They're all based on libaom, and libaom is not a production piece of software. It was designed to actually, formalize the standard, and so it had in it a lot of kind of overhead and cruft. And what that meant was that when you used it, you actually were seeing, maybe even just for single-threaded decoding, maybe 3.5 to 6 times longer to decode files than 264, right? So this actually, made it a much higher cost on your CPU. It would use more battery. It would generate more heat and things like that. And so this was a big problem. And so the Alliance recognized this problem and actually put out a call for proposals for a new AV1 decoder that kind of would address this, right? So it would take advantage of, or it would try to, get rid of the problems from having a large binary that used too much memory, and it explicitly called out the fact that, the CFP asked for full SIMD for all the platforms you care about, right? 32-bit, 64-bit x86, but also, ARM platforms. It needed to be multi-threaded, but it also needed to be bit identical in decoding to all the features of libaom, right? So this is a fully compliant AV1 decoder that's high performance, and it's also BSD licensed, right? And so that means that people who are building products can take this, modify it, maybe replace large chunks of it with a hardware portion or some other portion, and get the full advantage of being 100% AV1 compliant, even if the majority of their use cases go through this one path that they've optimized. All right, so we put out this call for proposals. The French nonprofit Videoland was selected, and the David project was born, right? So David is an AV1 decoder, is a recursive acronym, sort of like GNU and Pine and other ones. So the David project had a couple of goals. It was a joint project between Videoland, FFmpeg, and 2 Orioles, and it had the goals of having a small binary size, had low CPU utilization, was multi-threaded, and was cross-platform. And the way they ended up achieving this was through sort of classic FFmpeg fashion. They wrote a lot of handwritten assembly, right? They went in and profiled and tuned and, basically every time there was a few percentage they could get, they would do like that crazy thing you do with an assembly to like squeeze out like all those extra cycles, right? Like no cycle left behind. And so this actually means that right now in David, there's more assembly files, like more lines of code of assembly than C lines of code. So it's really more like a C compatibility layer around this assembly decoder, which is pretty incredible. It has a BSC license for all the same reasons we talked about before. And, oops. So the thing that's really interesting is, they had this contract that they signed on the 22nd of August. It took a little while after the CFP they're selected. But within like 3 months from being awarded the contract, they had like the 0.10 release out that was 100% compliant, and then it made its way into VLC and into Firefox, into Chrome shortly thereafter that. All right, and so the most recent release, which is this 0.3 release, I think 0.4 is just about to be released. It may have been released while I was making these slides, we'll see. This is the 0.3 release, and you can see that for the these are 3 different clips, and for the 3 different assembly platforms that we care about, right? 32-bit SSSE3, and then SSSE 4.1 and AVX2, that the David decoder does indeed get, 2 to 5 times faster decoding than libam at the same time, right? So libam has been improved along while this work's been done, and it's still achieving this incredibly high throughput. Okay, and so it does that, of course, by making use of all this multi-threading. And so if we were to take, David, and you were to use like this this Zen processor, and you keep throwing threads at it, it just keeps scaling. And we actually, kept throwing threads and just maxed it out. And what this means is that if you have very large workloads, either very large videos, like many, many tiles, very, very wide, or you've got just a huge amount of them, you can actually scale this nicely with your processor. So that should let you do things like, cloud transcoding and things like that in a very efficient manner. So interestingly, we also tested on a number of mobile platforms, right? And so here's a wide array. I think this data was actually taken back in January. And so you can see that, this is 1080p decode speed across all these things. And if you look at the A12 chip there, it's actually getting 120 frames a second, right? And so that means that you could potentially do 4K on mobile. And the last time I gave this talk, someone said, that's insane, like, is that really true? And so today, I have an iPad Pro. And so here's VLC, and here is a clip that is 4K, and let's move it back here. All right, and here it is decoding, 4K on a mobile device, which is pretty insane, I think. All right, so moving along. I wrote a blog post about the release of David in Firefox, and one of the things that we did that was really interesting is we actually started adding telemetry to track, which codecs were being decoded in Firefox. And so by the time that blog post came out, we actually had data from the past few months, and you can actually see that, AV1 playback is ramping up inside Firefox. And so this is the proportion over all codecs that we're seeing AV1. And so in February, we were seeing, I think, like 1 point something percent, and then in March, this number is actually low. I think it was closer to like 6%, and by April, we were up to like 11%. And so that's actually a significant amount of content that's already AV1. We don't know where that's coming from, because when we do this telemetry, we only record like which codec was being used, right? Like we don't know which URL it's from, and we don't know what you're watching when you're in your browser. But we have an idea, because back at DMUX last year, Steve Robertson gave this talk, and it was a talk on something else, but at the beginning he had this like 30-second, AV1 update where he basically explained that, they're currently doing, this is back in October, they were doing, a gigabit per second of AV1, and by the end of the month they wanted to be at a terabit, and that, I expected that they just kind of like continued to march along. At the time, you could go into YouTube/TestTube, and you could enable, give me AV1. It would be for 480p or lower videos. Sometime in the early part of the year, we noticed that they were serving 720, and I think right now, if you go every 720p video I've tried, like, it is being served in AV1. There was a little bit of a snafu about a month ago where they wrote this announcement that, hey, they had to pause AV1 rollout. People like noticed that they weren't seeing AV1, and so that same Steve Robertson came on Reddit and said, hey, we stopped it, but it's for some boring procedural thing. I'm not entirely sure what that was, some standards thing. But made this comment that it's actually performing well, and that they were going to roll it out for further use. So that seems like a very positive statement, and maybe overcome some of the earlier comments about how it wasn't cost efficient in production. Who knows, right? We'll wait for them to talk about that. All right, so I went back and last night went and pulled the new telemetry numbers, right, because it's been a couple of months, and so we can actually see that pause, right? So this is now that same data set, but it's extended through the months of May, June, and July, and you can see there's like about a 1% drop, so we're down from like 12.5 to maybe 11 something. But it's still pretty crazy that about 1 in 8 of the videos in Firefox is already AV1. All right, other notable things, I'm wearing this shirt here, so Mozilla and Vimeo co-hosted this Big Apple video conference in New York last month. It was a pretty exciting event because it's the first time we've done anything like that. We did it out of their space in New York, and we had 8 different talks from these like very excellent speakers, and they were all sort of different and brought some like different perspectives in. There were about 120 people who showed up in person, and we streamed it out live where you could ask questions remotely, had like remote participation, even anonymous remote participation. And we got about 1,000 people. So we are considering this kind of a big success. One thing, if you're interested, I'm going to talk about a few of the talks very briefly, but if you're interested, all the videos that we recorded and captured are online, and I think they're actually in AV1 right now because Vimeo has started using Mozilla's AV1 encoder in production. All right, so one of the things I wanted to mention that came out of this, Big Apple video was this talk by Ronald of Two Orioles. And so I like this graph because I haven't seen anything like this before, and it sort of gives you a very high-level picture of what the encoding space looks like on a complexity basis, right? So what you're looking at here is you're looking at a bunch of encoders that have encoded the same video with different speed settings, right? So you take the clip and you code it at different speed settings and you vary your rates, right? So you get these curves and you then compute BD rate. And so using as an anchor this top right value, which is his Eve encoder, using that as an anchor, you can then see the percent, how much worse the other runs are at the different speed levels, right? So this tells you, if I'm willing to have compute that's this high, what is the benefit? And it's sort of normalized in a way that we can then compare them, right? Because sometimes if they're not normalized, it's hard to compare. And so what's nice about this graph is it sort of does two things, right? It shows you some of the limitations of doing comparisons across codecs, right? So a lot of these lines don't overlap, right? So you can't actually say that, at the same complexity budget, this thing was better because the lines don't even overlap. So you can't say like, well, if I were to run it faster, like, would I still be better? You don't know. And so this graph sort of demonstrates that limitation. But it also shows a couple interesting things. So if you look at the very light blue small segment in the middle, that's his VP9 encoder. So I've never seen results he's posted for his VP9 or AV1 encoder. And you can see that there's actually operating points in AV1 where this VP9 encoder, corresponds with in terms of performance, in terms of like, how well it compresses. So that's actually an interesting result. And if you look at the yellow line, again, they don't line up, right? So he's using more compute than libVPX did, but he got better compression. So again, it's hard to say, what that really means, other than maybe he found some interesting ways to do that comparison. But the part that's really good, I think, in terms of, I don't have a mouse, really good in terms of, what we're looking at in terms of the AV1 encoder space, there's this gigantic gap, right, between the reference encoder and his encoder. And that means that there's this huge space of operating points that have yet to be exploited, that could be taken advantage of by, say, an open source AV1 encoder like our work we're doing, or other commercial encoders that's very, very broad, right? So that means there's lots of things we could do there. Another way, one of the things that would be nice, right, is if we had some Oracle function that could tell us, like, this is the very best thing you could do with this format, right? And we don't have that. We have these encoders that work kind of by proxy, right? You run the encoder, and all you know is that this encoder did this well on this clip, but you don't know if that's the best you could do, and you don't know if there's some trick of human perception you could exploit more to get better compression, right? Like, that's not something you can really know without doing a lot more research, and even then you're just going to get close to it. And so, what you would really like to do is you'd like to say, what if someone had, already done this work for one codec? They tried very hard to make their use case at one complexity budget work very well, and then they tried to do the same thing with another codec. And so one of our other talks actually did just that, right? So Cisco came and did a presentation where they talked about their Cisco AV1 encoder that will be part of their interactive application. And so what they've done there is, they've been doing optimizations on the 264 encoder they have for like 16 years to get that to work very, very well. And then they've now produced another encoder using AV1, and we were able to compare them, right? And so we think, the difference there is actually at the same complexity budget because they have the same real-time deadline. So when you compare them, you might be able to say something about the improvements between the codecs. And so what they showed was, by that I mean formats, what they showed was that for 720p with AV1, they're able to do the same quality at half the bandwidth, right? So that's a 50% fewer number of bits. And that they could actually do 1080p 30 using 2/3 of the bits that they had for 720p 30 264. And so the conclusion that Thomas Davies made was that, this actually represents like a step change in capabilities, right? That AV1 actually provides like a significant improvement over what they can currently deploy. And that it also has a bunch of tools that are all in the same profile, so things like screen coding and things they use for interactive applications like playing movies remotely. Like they actually showed where you can watch YouTube and have it stream across their system. That they can take advantage of a lot of the tools because they're there by default. And so to kind of illustrate what I was saying before on the previous graph, he also had this concept of a golden triangle. And so here, what you're looking at is that space between the theoretical RD curves for two different codecs or two different encoders, right? But really I think he's serious on two different codecs. And so what you want is you want to have a very large space between these, because what that lets you do is it lets you find operating points for different use cases that are a meaningful improvement as you move from one format to the next. And so when you're doing this comparison, you would like it so that when you design your standard, that space is broad, right? And you haven't excluded use cases that you had before. And you do that through techniques like we just heard in the previous talk, where you ensure that the essential coding tools, the ones that you must run, like the entropy coder or the coefficient coder, transform blocks, those are all still fast, right? Like you can't just add new tools that are better but slower because you've then narrowed that triangle. So I thought that was a really interesting description that I hadn't seen anywhere else either, so I thought that was a very nice takeaway. And so if you're interested in hearing the rest of these, all the talks are online. All right, so at the NAB talk, I had this list of all the AV1 encoders that I know about, and I was calling it this sort of AV1 encoder ecosystem where you've got open source encoders, you've got some closed source encoders, and so I've added the ones I just talked about to the list I'm kind of carrying around. And what's neat about this is, we've got this variety of open source encoders, but we've got this variety of closed source that do different things, right? Some of them are using FPGAs, some of them are hardware, some of them are software, some of them are for real time, and so we've, got people who are looking in that golden triangle to try to make, an encoder that suits their particular need. And there's probably a lot more that I don't know about. I think other people are working on these. I wanted to mention that, last year at the end of my talk, someone asked about AV1 and RTP. And so there is an RTP draft, but there's also support for AV1 in all of these other formats. And they also asked about AV1 and WebRTC. And so I was at IETF 105 last week, and at the hackathon, Dr. Alex from Cosmo did this demo of WebRTC using libaom in real-time mode. He had binaries if I wanted to play around with them. And then I also saw that last week, Vision Alert had a blog post where they also had an implementation of WebRTC. And so this is a thing that can be done. People who have been saying that AV1 is too slow for real time, there's now at least 3 different proof points I can point out and say that it is possible. All right, I wanted to kind of now change gears a little bit and go back and talk about, like why we are interested in seeing improvements in video compression, right? So if you look at this graph, I had this graph last year. This is the study that Cisco did about what we anticipate for how much of all internet traffic will be video. It says it's going to be projected to be 82%. We'll see in 2 years how close that is. But I wanted to maybe kind of illustrate like what is that, like of that 82%, like where is it coming from? And so I have some data points. So YouTube says they've got 1 billion hours of video that is watched per day, right? So if you convert that, that becomes 114,000 man years per day. And so to kind of like understand the scope of that from like a human scale, I have this comparison to like, how many man years did it take to build the Great Pyramid of Giza, right? Like this is a monumental undertaking that took, I think 20 years. So does anybody have a guess as to how long that took in man years? All right, I'll tell you. It was 131,000 man years. And that means that every day, like we're devoting the same amount of effort to watching cat videos as it took to build a pyramid. And notably, like 60% of it's on mobile, right? On Facebook, you've got millions of videos that are uploaded, and billions of them are watched every day. And all this video is getting bigger, right? So most of this is standard definition. When you go to 4K, you've got 4 times the information content. When you go to HDR, that's another 25% because you got to use 10-bit. And so, all those videos that are being watched are going to get a lot bigger and are going to use a lot more of this internet traffic. And so if we just look at the broadcast space, this was another thing that came out at NAB was that the 2019 Encoding.com Global Media Format Report came out. And so what I did was I went back and I found the older ones and I plotted just these 4 different formats and their percentage of the total amount of ingest that they're processing. How is that changing over time, right? And so in the blue is AVC. And you can see that as you go from year to year. In 2014, it was 69% of their ingest, and now it's up at 82%. But that really doesn't tell the whole story, because if you look at the size of data they're processing, it went from 0.95 petabytes to 20, almost 20, right? And so that's a ridiculous amount of video that's being encoded in 264. What was that? 5? All right. I got to move quickly here. So I thought that was really surprising. Why was that surprising? Because that standard is 16 years old, right? So this was standardized in 2003, and like these are other things that were new in 2003. And we all work in high tech, and we kind of expect to see, improvements in technology, come to us when they're available, right? And so the question I had was, like, what is going on here? Like, why is so much content encoded in 264? And the sort of top line answers are, well, it works everywhere. There are good open source encoders in this ecosystem. There are these mature workflows where you can integrate very well. There's a lot of momentum in the industry, and it has this predictable licensing model, right? And so, what's wrong if we just keep doing this? And the problem is that, your bit rate's too high, so delivery costs can exceed, the cost of encoding, right? So like you're going to use more bits to send it out on the network. It means you can't reach certain parts of the world that don't have that much network. There's not enough. There's no features for new experience. So people demand 4K and HDR, but they also want 360. There's AR and VR, which have even higher demands. There's cloud gaming, right, which is like even more demanding. And we're already getting close to the capacity of the internet, right? At 82%, like that's a lot of the internet that's just doing video. And that means like, what happens if we like reach that capacity? What happens if we have essential services that are on the network? And we can do some packet shaping and maybe prioritize them, but if those essential services are also video, like then what happens, right? So this is a big problem. And so, why haven't these other formats addressed this need, right? And the challenges are basically the same points we had before. One format doesn't play everywhere. We've got this poor open source encoder ecosystem. There was only one really good VP9, it was only one VP9 encoder, and it wasn't that great, as I showed on the previous slide. X265 and SVA HEVC were not as mature as X264, and there's this long proc cycle, right? And of course, there's this unpredictable license model. And so all these things contribute, right? Well, it's not just one factor. They all kind of contribute to the fact that none of these formats really took off, despite the fact that they were better technically. And so I have a demo. I think we're running a little low on time. And so I'm going to, I don't know if Brian wants to say a few words about this demo. I'm basically done with my section, and I will turn it over to him.
Okay, I'm Brian Vibber from Wikimedia Foundation. We do Wikipedia. Let's see. Ooh, how do I get to the next slide?
Page down.
Page down. Ah, there's a page down button. Awesome. All right. So one of the things that we've been looking into at Wikipedia for our video support is moving off of some of the older codecs into AV1. For complicated legacy reasons, we're really into VP8 and VP9. Which play pretty well across most of the major browsers, but not quite all. And we're really hoping that AV1 will give us the same abilities, but with a better bitrate ratio, et cetera, and more future-proofing. So we put together a little demo of trying to actually encode some stuff using open source tools and making sure that they actually work. So we're using FFmpeg as the basic tool set. It's pretty standard. Everybody uses it. As an encoder, we picked SVT AV1 because it scales to many processors, and you can do really fast live encoding. For the streaming, we use Dash because there's built-in support in FFmpeg for producing Dash. We did have to do a couple of patches. SVT AV1 needs to be hooked up to FFmpeg, and that's still a work in progress. And FFmpeg's Dash muxer doesn't actually grok AV1 correctly, so I put in a quick little hack to make that work. Now, in theory, we've got a server over there with 56 cores in it, and we're going to run a 1080p live encode along with a 480p second stream on the same Dash manifest. Now, we're not hooked up to project, so you're just going to have to trust me that this tiny screen is working. Excellent. Shouldn't take long. Okay. So hopefully, in a few seconds, this will start playing back some video. Oh my God, is it actually working? Now, this is actually playing in 3 separate browsers. So in Firefox, oops, Firefox needs to be refreshed. That's okay. We'll worry about Firefox later. Anyway, Firefox and Chrome use David natively, the decoder, which is very fast and runs pretty fantastically on just about every machine I've thrown it at. Safari, however, is somewhat more difficult. We've actually ended up creating our own WebAssembly port of David to do in-browser decoding as a fallback mechanism. It's currently limited in resolution to about 480p on a fast machine, but it actually does work. And we're hoping to continue work on that as WebAssembly continues to mature and gains thread support, which actually works in Chrome, but not yet in Firefox, or not in Safari or Firefox. We all know about Dash streaming. And we're about out of time, so we're just going to go past all this. There's a couple of links to details in the slides, and then I think we are good to go. All right, Nathan, any final words?
Are there any questions?
Are there any questions?
So we're at minus 60 seconds, so
perfect.
There are no questions right now. But we'll happily trade questions for Dash and AV1 demos, so thank you.
Great.
So I want to thank Nathan and Brian for that session.